Right, good morning everyone. Welcome to one of the Solutions PT Industrial Network webinar series. This morning we're going to look at troubleshooting Ethernet and IP networks with myself, Ian Bailey, the Product Manager for Industrial Networks, and Ed Stania.
Morning Ian, morning everyone.
Who's our Network Specialist. So as always, I'll quickly introduce Solutions PT, so I think most of you will know us. We're very well known for the Wonderware brand, but as you can see below we have many others, and our technology partners can be seen there. In particular, I draw your attention to Clarity and ask you to look out for the webinar that will be coming up shortly to introduce that product, and ask you to check out the website for the Clarity page.
Thanks Ian. Right, so the agenda for today's webinar. 4 things we're going to be looking at. The first 2, we're going to have a look at the kind of best way to approach troubleshooting networks. So we're going to kind of look at some methodical steps we can kind of follow to troubleshoot connectivity issues that we might have on a network. We're going to have a look as well at some of the most common causes, most common causes we'll find that will cause us connectivity problems on our automation networks. And we'll take a little look at some useful tools that will kind of help us troubleshoot and resolve those issues. So we're just going to start off with kind of a little bit of theory, you could say. And a good way to kind of approach troubleshooting networks is to always remember that whenever a network device wants to communicate with another network device, there's always a methodical order that it will take when it comes to processing and sending data. So every single packet from one device to another, and this is whether the device is a PLC, a HMI, a switch, a workstation, any device that lives on our network will always kind of follow this methodical order. So we can kind of use this order to give us some methodical steps to approach troubleshooting situation, and we can start kind of following a little bit of a process of elimination to actually find where our issue lies. Now this order, some of you might have already kind of come across it before, and we're going to essentially break it down into a bunch of layers, 7 layers, and this is commonly known as the OSI 7-layer model.
So how does this model help us with troubleshooting?
So while it is a little bit of a kind of theoretical model, it still does apply, as I say, to every kind of single network device. Every Ethernet or IP network device will follow this process. It will follow these layers to communicate with other devices on the network. So whilst it is theoretical, it gives you some places to start, and it gives you a bit of an order in which to investigate certain things on the network, things on the device, to help you kind of get to the bottom of where the issue lies and help you resolve it in the most kind of efficient and quickest way. So looking at this 7-layer model then, if we just kind of start at the top, and obviously at the top we've got our end application. So this is the application we've got on our device, whether it's a HMI, whether we're using a workstation, we've got email on there, whatever it might be. This application layer is where we kind of see our network data interpreted. So for example, on a SCADA terminal, if a pump was activated somewhere and a PLC sent a message to our SCADA workstation, the application will interpret this as kind of highlighting a graphic or showing a graphic start moving on the SCADA screen. So that's what our top layer is, our application layer. Moving on below that, our presentation layer. This is where essentially we deal with things like encryption and compression. Now this layer isn't particularly as relevant as some of the others will be, especially in automation networks, but we will kind of go into a little bit of detail with it in a bit. Layer 5, so our session layer, this is essentially where our device builds and kind of closes sessions down. When we talk about sessions, we're essentially talking about our device keeping our data streams separate from each other, so we're able to obviously have multiple kind of data streams to different devices. We can talk to lots of different devices over lots of different protocols, and they're all kind of handled in their own individual sessions. Now, perhaps our more important layers, 4, 3, 2, and 1. So 4 is our transport layer. this is the kind of high-level layer that essentially moves our data from one device to another. So we use a transport protocol. You might have heard of TCP, UDP, something along those lines. Those are kind of the most common protocols we'll use to move our data around the network. Our third layer, our network layer, this is where our IP addresses come in. So when we're communicating with different devices on the network and with assigned IP addresses, this is kind of all handled at the network layer. And this is also where we'll be handling routing. So if we've got multiple VLANs or multiple networks that need to talk to each other, this is all handled at this network layer, layer 3. So this is obviously a very important and fundamental layer within the network. And if stuff isn't working here, then obviously we're not going to be able to communicate at the most basic of levels. Moving on down from that, we've got our data link layer. So this is where we essentially handle the Ethernet part of networking. This is essentially where we build our kind of frames, and these frames get sent from device to device. It's where we deal with MAC addresses. So if you can kind of, an important takeaway point from this is our data link layer, we deal with MAC addresses, our network layer, we deal with IP addresses. And finally, down at the bottom, we've got our physical layer. So this is our actual physical connection into the network, whether this be over our kind of traditional copper cabling, whether it be wireless or any other form of kind of medium that we can send our data physically from one device to another. This is all handled at this very bottom layer. So this is where we're essentially handling with binary, zeros and ones, on and off, electrical signals, that kind of thing. So we're just going to have a look at some kind of high-level troubleshooting points for all the different layers. And these are just quick, simple questions to ask yourself to start following these seven steps to troubleshooting your connectivity issues. So if we start right at the bottom, we start with our physical layer. And the reason we start right down at the bottom is, let's assume we've got two devices that can't talk to each other. Now, before we dive straight into the application or the configuration of our PLCs, the first thing we want to do is actually check if our devices have got a connection to the network. Because if they don't, then nothing else is going to work. So first and foremost, we start at layer 1, the physical layer. So we're going to ask ourselves, do we have a connection to the network? Is our network port lit up on the switch? Is our network connection and window showing us connected? That's a nice simple one to kind of troubleshoot. We either have a connection or we don't. Second layer, data link, is our network card operational? So is it installed properly? Do we have the correct drivers for it? Because this is essentially where the fundamental part of our network card operation lives at the data link layer. It's up to the network card itself to build our frames, handle MAC addresses, that kind of thing. Layer 3, our network layer, do we have an IP address assigned? Not only do we have it assigned, is it correct? Do we have a correct subnet mask, the correct gateway, that kind of thing? That's what we'd be checking at layer 3. Layer 4, our transport layer, can we open our TCP or UDP connections? So things that could potentially stop this might be a firewall, whether it will be a local firewall to our device or whether it be a network firewall. Those are the kind of things that could be preventing us from opening these connections. Layer 5 kind of ties in a little bit with our transport layer there, and it's a question of are our ports being correctly opened or are they being blocked? So again, it does kind of tie in a little bit with issues with firewalls, things that could be blocking our ports. It might also tie in with whether that port in question is already in use by another service on our device. That would be something to look out for at that layer. Layer 6, a slightly less important layer, but still we can ask ourselves here, if we're using something like encryption on our network, are those services running correctly, are they configured correctly? Because if they're not, this is where we could have an issue at this layer. And finally, our application layer, we're going to ask, is our application configured and working correctly? Have we configured it properly to talk to the correct IP address on the correct port, that kind of thing. So the kind of thing that we look at when we talk about this 7-layer model and those points, those questions I've just gone through, is that every single time a device wants to talk to another device on the network, we kind of have to follow these 7 layers. We have to follow this process. So somewhere along the way, if we've got a connectivity issue, somewhere within those layers is going to be the issue, and that's 100% of the time the issue will lie within one of those layers, and it's just a question of finding out which layer it is, and once you've obviously found that out, the specific part of a configuration that is causing that problem. So really, when we come to troubleshoot, the most efficient and quickest way of doing it and resolving the issues is to kind of systematically work through these layers one by one, and it gives us this process of elimination. Eventually, we'll find the root cause of where the issue lies.
Yeah, so the models, I think, fit together quite intuitively, but from your experience, which layer is the most common one for seeing any problems present?
I would say in most cases it will probably be kind of layers 3 and 4. So if I just go back a slide, this is kind of where our IP addressing comes in and where our ports, TCP, UDP ports come in. Most commonly this is where we'll see the issues: misconfigured IP addresses, misconfigured ports, firewalls blocking the ports, that kind of thing. Most commonly that's where I see kind of a lot of issues. And also that's probably the most kind of complex part to the troubleshooting is within those 2 layers. Like I say, the first couple of layers, especially layer 1, are very easy to troubleshoot. You're either connected or you're not. With IP addresses and ports, there's obviously a little bit more investigation that has to be done there. It's a little bit more prone to human error. You might have accidentally mistyped an IP address, a gateway, something along those lines. But really, that's where we kind of see the brunt of issues within layers 3 and 4. So we're just going to go through the 7 layers in a little bit more detail just to give you some kind of pointers as to what to look for and how to start kind of troubleshooting. Now, as I say, layer 1's nice and easy. This is our network connection into the network. And it's either working or it's not. And if it isn't, it could be as something as silly as you've got the cable unplugged, you've got a faulty cable, the switch port is incorrect or faulty. And obviously ways in which you can kind of prove that is trying different cables, trying different switch ports. It's quite a simple layer, as I say, to kind of get to the bottom of. There are instances where if your switch ports and your cables are okay, it could be a driver issue on your device that's actually causing the problem. So things like that to investigate.
Yeah, so I can certainly understand that if you can see the port and the light's not there, it's relatively obvious if it's functional or not. But a lot of the networks that we'll see, it's not necessarily that easy to access the physical port, and you may have a large network with many switches, many cables. In that case, how can you resolve that issue in a relatively sort of short period of time?
Yeah, I mean, that's a good question. Obviously, in larger networks, it becomes a little bit more problematic to get to the bottom of an issue at this layer. Let's say you've got, 15 to 20 switches and you've got 2 devices can't talk to each other at different sides of a network. This is kind of where your network visibility becomes really important. So it's understanding how your network looks, where your connections are, and being able to kind of trace those connections and see if they're connected or not. So something like Hirschman High Vision is extremely useful in that situation because it does all that work for you. It maps out your network, it shows you where your switches are, it shows you how they're connected to each other on which ports, and it will obviously show you if there's a breakage in your network, there's a breakage in one of the cables, and you've got a connectivity issue between a couple of switches. It will give you a nice little a GUI interface that will show you all that. It saves you having to obviously physically go around each switch, checking the uplinks and that kind of thing. So really that's why visibility of your network is extremely important, particularly in big networks. It can make life a hell of a lot easier when you're investigating a physical issue. So layer 2, our data link layer, this is where our kind of network card handles building of frames. So when we talk about frames, we're talking about Ethernet, we're talking about MAC addresses. So it's up to the network card to be able to build those frames, put the data into a frame, and obviously set up the source and destination MAC addresses. So if you've got an issue at this layer, and if it's a device issue, so an issue with just a particular device, it could well be that an actual issue with the card itself, a network card, the interface, and that could be a software issue, so faulty drivers. It could be a hardware issue that the card has just failed. If you've got a connection to the network but you cannot send a single packet or a frame anywhere and it's just local to this device, then there's a good chance that your network card or your drivers has kind of failed somewhere there. If your problem is a little bit bigger and it affects a much larger part of your network and not just a single device, then this suggests that the frame cannot get around a network. It can't get from switch to switch. And the way that a frame gets from switch to switch is each switch will have a MAC address table. It will know which port each MAC address is down, and it will make a decision where to send that frame when it receives it. So if a switch is failing, if for some reason you've got some invalid MAC address entries in the tables. That could also cause the issue as well. So at this layer, it's MAC addresses that you want to be focusing on. And a MAC address table is reasonably straightforward, in which it's just a port to a MAC address, a simple kind of conversion. So those are the things you want to start looking at this layer. So network layer, layer 3, this is probably where I see most connectivity issues, somewhere at this layer, and this is where we obviously, as I say, we deal with IP addresses. So if your IP addresses are incorrect, your default gateways aren't properly set, or your subnet masks are incorrect, these kind of things can cause an issue. If it's an individual device issue, then yeah, the first thing I'd be checking is the IP address correct? Can I ping other devices on the network? Can I ping myself? Because it could also be a software issue at the device layer where the IP stack is corrupt, something along those lines. At the network level, then it will most likely mean that you've got some kind of routing issue. If you've got two networks that can't talk to each other, two VLANs that are struggling to communicate, there's probably some kind of routing issue. Things I'll be checking there is, are the gateways accessible? Can I ping them? Is the configuration correct? How does the routing table look? Does it look correct? Those are the things those are the kind of things that could, cause an issue at this layer. And also access control lists. So these are things that will obviously filter traffic at the IP level, and they could, be filtering traffic out between two VLANs and blocking it. So also that's something else I'll be checking on the layer 3 device, whether that's your router or your firewall. Layer 4, your transport layer. So if your first 3 layers all check out okay, but you still can't communicate between a couple of your devices, I'll be looking here at your transport layer. And this, if you've got a device level issue here, so if it's just a particular device that's struggling, chances are it means that it cannot either open the port, it can't connect to the port on to a particular device, and things that could be causing that to kind of not work correctly will be firewalls, software firewalls and hardware firewalls. So perhaps they are filtering out the traffic, you might have a misconfigured port number. If we get to this layer, we assume that our kind of IP connectivity is okay. We can ping each other, that's all fine, but we can't open our port to our specific service, whether it's a web service, some kind of SCADA application server, whatever it is. So you want to be checking your kind of port numbers at this point, and you want to be checking if anywhere along the way on the network there's a firewall or layer 3 device that could be kind of filtering that traffic out. So again, ACLs, access control lists, you'd want to kind of be inspecting those at this point.
So we say inspecting the access control list, but what within that are you actually looking for?
So you kind of want to be looking at your rule set. The first thing you want to obviously do is look at which device can't talk to which other device, get the IP addresses for them, get the ports that they're trying to communicate on, and with that information you can look at your access control list and you can see if those details kind of match up with your ACLs. Is there a rule in that set to allow that device to talk to the other device on that port? If there isn't, then that's probably where your issue lies. If there is a rule there and you know that traffic's getting passed through your layer 3 device, your firewall, your access control list, then chances are the problem isn't at this layer, and that's most likely where you'd want to move up. So the layer 5, a session layer, this is a much less common place for issues to start happening. This and layer 6, not as common that you'll have problems here. If you do have a problem at layer 5, it kind of implies that the operating system, the thing that manages your kind of network connectivity, it's unable to build and manage the sessions. So your session layer is what, as I said before, keeps your kind of data streams separate from each other, and it does that via port numbers. So an issue at this layer would assume that for some reason you cannot open that session, for whatever reason that would be, and this is why this is quite a rare kind of occurrence at this layer. It could only kind of be a problem with, let's say, a server that's receiving connections if you're trying to load an application that uses a port that's already in use. And there's a little tool that we can use, particularly on Windows machines, that will give us some information as to which ports are in use, which ones we're kind of listening on, and that can kind of give us a bit more information as to troubleshooting this layer if we do need to. If we're talking, though, about a network level issue here, then the only other thing that you would probably want to be looking at is if you're using a WAN device. So if you're local devices can't communicate outside of your local area network. They can't go out to the internet for whatever they need to do. That could be that your router, your layer 3 device, is not properly building these network address translation sessions. So that would be something to check if you don't have internet connectivity from local devices, because that also would be a layer 5 issue. Again, layer 6, this is also a kind of rare place to find issues, particularly in the automation world, because we don't often always do a great deal of kind of encryption and worry about presentation services here. But essentially an issue here would be with things like encryption, compression, that kind of thing. And they are quite rare at the network level to come across these, and unless, of course, you're using a kind of next-gen firewall that does filtering at the upper levels. So traditional firewalls will just filter by your IP addresses and the ports, that kind of thing. The kind of next-gen firewalls will do a little bit more than that, and they will start filtering at the higher levels, and they'll start inspecting the kind of the underlying data. And they might be interfering with encryption services, things like that, and they could be causing an issue.
So the firewalls would be an example of where we might see an issue here, but really what you're saying is it's unlikely to present here.
Yes.
Think about whether you check the other layers below it before you stop worrying about this.
Exactly, yeah, exactly. If you've got to this point and you've still got an issue, chances are it's probably at the application layer. But there are a couple of things that you should possibly check for here. And if you are using encryption services between the two devices that have got a problem, then you'd want to check the configuration of those and just do some basic tests to check that they are working correctly. If you've got through all the other 6 layers and you've still got an issue, then there's a very, very strong chance your problem lies at the application layer. So what is happening here is 99% of the time, if you've got here, the data is being received, it's being processed correctly, moved up the layers, the application is receiving it and not interpreting it properly. Or there's a misconfigured port, there's a misconfigured username or password, something along those lines that's stopping that data being interpreted by the application and doing what it should do. So actually, application level issues, they are quite common because, again, when you configure an application, they're prone to human error. You've got to set up IP addresses, ports, put in usernames and passwords for authentication, that kind of thing. So if you've got an issue and you've got to this point, then what you want to be checking is the configuration of your application. You also want to start looking at things like log files, because chances are, although the application may not be doing what it should be doing, somewhere, hopefully, there's a log file entry being written explaining what's happening, explaining why it isn't working. It might not be obvious to you until you start diving into the log files, Windows Event Viewer, that kind of thing. So those are the things you want to investigate when you get to this point. So now we're just going to quickly go through a couple useful tools you can use then to help you troubleshoot, and these kind of tie in with some of the different layers, but really these tools are a nice, quick, easy way for you to prove connectivity at just kind of the first few layers, and to hopefully eventually get you to the point where you can confirm the issue is at the application layer, for example. So your MAC address tables, if you've got no connectivity between a couple of devices, check your MAC address tables. On Windows, you've got a nice little command for it, the ARP command, which will show you your IP address to MAC address conversions. Your switches will also have MAC address tables, which will show you your MAC address to port conversions as well, so it will show you which ports frames are being sent down, and those are the kind of things you want to start checking to prove your issue kind of isn't at layer 2. Everyone's probably heard of ping. Ping is a kind of suite of protocols, and kind of ICMP protocol suite that will allow your two network devices to kind of test the most basic form of connectivity with each other. So this is all happening at layer 2 and layer 3. There's no kind of ports involved here. There's no upper level application stuff going on here. It's just a basic connectivity test between two devices, and it'll help you to kind of ascertain if you've got that IP level connectivity. The only thing to look out for here is if you do have firewalls, they might be blocking these pings, and it might inadvertently send you down the kind of wrong route when you're doing your troubleshooting. Your connectivity might be fine, but it might be your firewall that's blocking it, so that's just something to be on the lookout for. If you find yourself getting to a point where a lot of your troubleshooting is just not giving you anything, if you want to kind of have a bit more of a deep dive, there's a lot of kind of network analysis tools out there, and probably the most common and one of the best ones I've used is Wireshark. What Wireshark essentially does is show you all the traffic to or from a local interface that you've installed the software on. So this will show you absolutely every single packet being sent to or from your network interface. It will show you in its most basic form. It will allow you to actually ascertain if you're receiving a packet or not. It will help you to kind of troubleshoot if a switch is behaving as it should be or if it's not. If you can't see it in Wireshark, it means your device hasn't received it, and you want to start checking other parts of the network to see where it's getting lost. The only little quick tip I'll give with Wireshark is to use filters, because there's that much data that you'll get from Wireshark, particularly on a busy network, interface, that you'll be absolutely overwhelmed by it. So filters allow you to obviously just show you the traffic you want to see. So if it's just one device you're having trouble communicating with, you can put a filter in to say, just show me traffic to or from that device. Don't show me anything else. They are very important to use with Wireshark. And the kind of ultimate in troubleshooting and really super deep dive here to find out what's going on the entire network if you've got some very kind of obscure behavior going on that you just can't pinpoint, that would be to use port mirroring and Wireshark. So what this essentially does is it allows you to, now this can only be used on managed switches or managed routers that support port mirroring, but most do nowadays. And it will essentially take a copy of every single frame on the ports you specify and send it down your mirrored port. Now what you can do with that is you can then load Wireshark and essentially receive traffic for the entire network, or at least all the ports that you specify in your port mirroring. So with this you can start troubleshooting devices not local to you. So for example, a couple of PLCs might be having trouble communicating with each other. You can't install Wireshark on your PLCs, but you can mirror the ports that they talk on and then receive the traffic with Wireshark and start analysing it and see what's going on kind of at a really super low level. That's everything from me.
Great, well thank you very much for that, Ed. Very interesting. For those of you out there who may be experiencing any troubles with their industrial network or just want to learn more about it, then I'd recommend the Industrial Network Audit. And certainly what we've seen from that is a range of findings, not just pointing out how we can improve practice and performance of the network, but also through the troubleshooting process, we've seen some quite deep down issues that would have been quite difficult to resolve otherwise. And if you're intrigued by industrial networking or think it can improve how you do your work currently, then I'd recommend the Industrial Network Training course. I haven't done it myself. Actually applying these principles and a lot of the other principles we talked about in the webinar series in a lab with hardware and with expert instruction is a really good way to bring on your knowledge. So for any more information, you can see the contact details in front of you, and I'd like to move on to any questions. And I think what I'd say to yourself, Ed, is there might be people out there with challenges on their networks now. You clearly just talked through troubleshooting, but some of the principles in there may be a little bit obscure to them. Would you recommend anything in particular that we talked about in our previous webinar series?
Yeah, I mean, a lot of the previous webinars we've done, they cover quite a lot of detail really on a wide range of subjects. And so really, I guess it depends what kind of issue you're having, but chances are there is some useful information in one of the previous webinars that should be able to help you out there. Obviously, these are just a kind of high-level bunch of bullet points for you to get you on your troubleshooting ways, but if you want a bit more specific detail, yeah, there's a good chance one of the previous webinars we've covered quite a lot of the most common issues you might have on your network, and we've gone into some detail with routing and IP addressing and that kind of thing in some older webinars as well, so they might be very useful to look at, particularly if you're having a problem, with a couple of devices with IP addresses, VLANs, that kind of thing. The previous webinars, we do have some very good information on there.
Great, well thanks Ed, and there's a wealth of information out there. I'd recommend it to anyone. I think that's it from us today, so thank you very much.
Thank you everyone.
All right, bye-bye.
Bye-bye.